We are continuing where we ended with sets. We want to continue from us understanding the laws of sets, right? The laws of sets, and how we are going to be able to use those laws to be able to answer questions. So, when you're talking about laws of sets, we have got four important laws we need to know. Of course, not the only ones. The first law is known as the De Morgan's law. Okay, De Morgan's law. Now, the De Morgan's law tells us that when you have got a union or an intersection, let's say for example A intersection B, you can see these sets are in brackets and then they've got a complement. When you distribute this complement to what is inside, you end up with A complement and then B will also carry a complement. But what happens is that the sign on the middle will change to union. So this law that I've written here is known as the De Morgan's law of the intersection of two sets. Why? Because we are starting with intersection. So it's known as the De Morgan's law of the intersection. We also have the De Morgan's law of the union. This is where you have got A union B complement. If you distribute a complement, you are going to have A complement, but the sign changes on the middle, it becomes intersection, and then you are going to have B complement. So this is the De Morgan's law. It's not hard. Second law we need to know is known as the commutative law or the law of commutativity. The commutative law tells us that when you have got 1 plus 2, it's the same as 2 plus 1. So when you have got A intersection B, it is the same as B intersection A. So many times when you're working with sets, you'll be able to swap them. That's the same with A union B. It is the same as B union A. That's the commutative law. The third law is known as a distributive law. Remember, this is to distribute. So distributing, say for example, I've got x, y plus z. If you distribute, you are going to have x times y, which is xy, then plus x times z, which is xz. So that's the same way the distributive law on sets works. So if I have got A intersection, let's say B union C, what I'll do is I'll get this A intersect multiplied with B and then the A intersect again, more like you're multiplying with C also. So therefore, the way this is going to become is, this is going to become A intersection B, and then you get the sign on the middle here. In this case, it's a union. So get that union, then get the A intersect now, like multiply with C, so that will become A intersection C. You are going to do the same whether you have got union here or both are intersections or anything. All right, that's the distributive law. The last law is known as the associative law. Now the law of associativity or associative law is similar to this. Look, if you have got 5 plus 6 plus 7, when you add the 6 plus 7, the answer you find you add to 5 is the same as you first adding the 5 and the 6. Then the answer that you find you add to 7. So that's known as the law of associativity. So A intersection B intersection C is the same as A intersection B and then intersection C. That will be the same if you are using union. Please, associative law only applies when you have got the same set operation. Like you can see, there is intersection here, there's also intersection here. This won't be true if you have got a union and an intersection. It should be the same, intersection and intersection or union with union. Are we okay? Have I left out anyone? The other thing that you need to know are what I call as rules of sets. They aren't hard, but they are so necessary if you are to answer questions on sets. Let's say this is our set here. Let's say in this set you have got the set A, and this is the universal set. So universal set, we either use E, capital E, or we use U. So if you see any one of those, but we normally want to use E because U, you might be thinking it's union. So on the rules you need to know, when you get any set, intersection, and empty set, intersection means what is common. Empty set means nothing. So empty set, we can also write it like this. Just write curly brackets with, don't put anything inside, not even a zero. That's an empty set. So every time you're intersecting any set with an empty set, intersection means what is common. So there is nothing that is common between something and nothing. Hope you get that. So if I have and you don't have, what is common between us? There's nothing. Because me, I have, you don't have. So intersection of a set with an empty set is always an empty set. But that same set, if you take a union with an empty set, union means combining. So if you have, I don't have, if we combine ourselves, we are going to have. So any set union and empty set is that same set. And then any set intersection, the universal set. So what is common between me and the universe is actually me because I'm part of the universe. So every time you get the intersection of a small set with a bigger set, the answer is a small set because it is within the bigger set. And then every time you get a set union, the universal set, the answer is the universal set. Like you're the union of a big set with a small set, the answer is always the big set. Union means combining. Okay. Another thing that you need to know is that when you get a set, you intersect it with what is outside that same set. So look at this set A. What can you see inside and it's at the same time it's outside? So you can't find something inside and at the same time outside. So there is no intersection between a set with its complement. So that's an empty set. And then when you get a set union an empty set, the answer is the universal set because you are getting what is inside, you are combining with what is outside. Combining, what do you end up with? You end up getting everything. The last law maybe I should write is when you see A minus B means what is in A but not in B. It also means A intersection B complement. So you are going to see it like this if you write in a Venn diagram. Let's say this is the set A, this is the set B. So here is A, here is B. What is in A but not in B? So it is this region. You can see what I've shaded. That region is in A but is not in B because you can see I've not shaded the part that is in B. So that's A minus B. Are we okay so far? So let's talk about simplifying sets because that's why I gave those laws and rules so that we can be able to use them to simplify sets. So the first one, say they've told you simplify A intersection B intersection A complement, okay, like this. Now, when you are simplifying a set, what you are simply trying to do is you want to find the simplest form. The simplest form, you shouldn't have the same letter two times. Never have the same letter two times. So for this question here, what I'm going to use is I can start with a distributive law. I'm going to distribute A intersect to what is inside. Anyone that can give us what is it going to become? Anyone that is able to answer? So we're going to get the A intersect, we intersect it with B, so that becomes A intersection B. And then we get the same intersection symbol on the middle, which is this one. And then the A intersect, we intersect it with A complement, so that becomes A intersection A complement. And so this is going to be A intersection B intersection. Remember what we said, the A intersection A complement is an empty set. And we say that any set intersection an empty set is an empty set, because there's nothing that is common between any set and an empty set. So that is the answer there. Let's say again we are told for us to simplify. Let's say you are given M intersection N complement. Let's say intersection M, the complement here, and then there's another complement outside. Remember, simplifying is you don't want to see the same letter two times. It should only appear once. So what are we going to do in that case? We are going to get this complement. We distribute it to what is inside the brackets. So here I'm going to take this as one term. I'm going to get this one as one term. Okay. So we're going to get the complement which is outside the bigger brackets. It goes on the M. And then we are going to have N complement intersection M. It already has a complement, but now it's going to gain another complement. Remember what you said from the De Morgan's law, if you distribute a complement, the sign here changes to union. And then this becomes M complement union. Now again, remember when you have got okay, I didn't mention that, but when you have got two complements, they cancel each other. So this will simply be any complement intersection M. Those two complements have cancelled each other. At this point, what can I do? I'll distribute. So I've got M complement union. So the M complement union is going to go with the N complement or close. And then we'll get the intersection on the middle here. And then the M complement again is going to, it has a union, it will go now again with the M. So this gives us M complement union N complement. And then we have got intersection. Remember, every time you get the complement of a set union that same set, the answer is universal set. And we said that every time you get any set intersection the universal set, the answer is that same set. So this is actually M complement union N complement. If you want, you can also say this is the same as using the De Morgan's law. If you remove the complement outside, this becomes N M intersection N with a complement outside. Remember, when you distribute the complement, the sign changes from intersection to union. So these two are the same. So you can write any one of them. You have simplified. Does this make sense? Does this make sense, guys? Or people are lost somewhere? So it is this same principle that we are going to use to shade sets. So let's go to shading of sets. These are exam questions you'll be able to find. How to shade sets. So let's say they've given you the set A intersection A complement union B. It has also a complement there. They say shade. Now you can't shade the set before you simplify. So the first thing that you do is you simplify that set. That's when you can be able to shade it. So this will become A intersection, distribute a complement. So it becomes A complement complement. The sign changes, and then you're going to have B complement. Remember, if you have got two complements, they cancel each other. So this would be A intersection A. Okay, it will now just be A and then intersection B complement. Now, it's not necessary for me to distribute this to give me still the same answer. So if I want to simplify further, because actually it's a good way, you can simplify using a Venn diagram also. So to simplify this one further, what you can do is you can actually use a Venn diagram, because for me I can see the answer, but for you, you can't see it. You need to use a Venn diagram. For some questions, them simplifying might not be as direct. You need to use a Venn diagram. So look at what we are dealing with. A intersection B complement. Remember we said A intersection B complement is the same as A minus B. We're talking about what is in A but not in B. It's this region. So you want where this set which I've shaded is intersecting with a set A. The set A is the entire of this one. So can you see that where the two sets are intersecting is basically the same A intersection B complement, the same one that I've shaded. So this set here, simplifying it to the simplest term, the simplest form is actually just A intersection B complement. Why? Because A intersection B complement is actually a smaller set in comparison to A. So this is how you answer this question. Let's say for example we've got another one. It's A complement union A complement intersection B complement. There's another complement. They've told us to shade. So what are we going to do in that case? First simplify. I'll get the complement outside. So that becomes A complement complement. Remember this sign here, the union changes to intersection. And then we're going to have A complement intersection B. This one will also carry another complement. So I've got two complements. These two complements will cancel, so that will just be A intersection A complement intersection B. Even these two complements will cancel. Distribute the A complement, so we're now going to have distribute the A intersect. So we're going to have A intersect A complement, and then we're going to get this sign here, which is intersect. Distribute again the A intersect, and it will go with B. So A intersect A complement, we said this is an empty set, and then intersection A intersection B. And we said the intersection of an empty set with any set is an empty set. So if they said that show this in a Venn diagram, what you do is just write this. This is A, this is B. Don't shade anything. There's nothing to shade. Why? Because the answer is an empty set. So there's nothing to shade really. You need to know what is known as a disjoint set. If you hear the word disjoint set, it is a set where you don't have any intersection. Okay? No intersection. So if it's a set that has no intersection, they ask you to put it in a Venn diagram. Okay, let me use an example. They say shade the following given that A and B are disjoint sets. So what do we do in that case? So let's give an example of a question. Say we have got A minus A minus B. So we have got a complement here and another complement. So first thing first that we're going to do is simplify. So change the minus first. So this is going to be A. I'll change this minus. Remember minus means intersection with a complement on the second part. So this second part has got a complement. It will carry another complement. Why? Because I've changed the minus into intersection. Hope that is okay. And as you can see, those two complements will cancel themselves out. So we're going to have A intersection A minus B with a complement there. Now A minus B further, we can simplify it and it will give us A intersection B complement. Then I've got another complement there. Now I'm going to distribute this complement to the inside. So the first term, which is A, will carry the complement. The sign here will change to union. The A intersection B complement will also carry a complement. Furthermore, I'll distribute this complement which is inside to these two terms which are inside here. So it becomes A complement union. It will become A complement. Remember the sign here also changes. The B will carry another complement. So complement complement, that will just be a B, right? So I'm now going to close, right? And then what do we do further? Again, this one I'll just leave it here, because if I go on simplifying further, I'll just be, if I distribute the complement union with what is inside the brackets, it will still be revolving, it will still come back to it. Why? Because we have got union and union, so that will not make sense. So for this one, if I wanted to simplify further, the best I can use is a Venn diagram. So you see that sometimes questions that you be given to simplify, you might not necessarily simplify them without a Venn diagram unless you know, you can see, I can see the answer because I know the mathematics, but you might decide to use a Venn diagram. So we can start with this part. Let's shade A complement union B. So A complement union B, I'll shade it in red. A complement means what is outside A. Okay, what is outside A is all this region here, all this. Union B, union means combine. So shade everything what is which is outside A, also shade what is in B. That's the meaning of union B. So meaning that also reach here, including the part that is in A. So that's the difference between union and intersection. So what I've shaded is A complement union B. Now, where is it intersecting with A complement? So if I shade A complement, say I put it in blue, A complement will just be here. I'm going to put these dots. Okay, I'll write it like this. This is A complement. So can you see that where the red lines are intersecting with the blue shading is actually just a complement. So therefore, the final answer here is just a complement. So therefore, if I wanted to share this, but then the problem is for this question, I have been told that A and B are disjoint sets. So this is not going to be the answer, and this is not going to be the simplification. Why? Because they are disjoint sets. What are disjoint sets? These are sets which don't have an intersection. Therefore, the simplification is going to be different. So disjoint sets in a Venn diagram look like this. This is A, this is B. They don't intersect. Therefore, now we can shade. So for disjoint sets, A complement union B is going to be, again, since they've not told us anything about the universal set, this is what you need to know about disjoint sets. If they've not told you there is a universal set, what is outside A is actually B, okay? Because these are disjoint sets. So if something is not in A, then it is in B. If something is not in B, then it is in A. So in other words, A complement is going to be all of this, right? Union B. So union the B also are shaded. So this is A complement union B. We want to see where it intersects with A complement. So where is it? A complement again is just the same thing. So can you see that the answer is still just A complement? But I've told you that for disjoint sets, and specifically for this one, they have not given us information about their universal set. So meaning I'll just put them like this. So we are saying that A complement union B. A complement union B means shade what is outside the A and D together with B. So what is outside A is actually B. Together with B, also shade B. So that's the meaning. So this is A complement union B. You want to find where it intersects with A complement. A complement, again, we have said that the answer is no, it's not the intersection, but the union of A complement. Again, we have said that A complement is just B. So for this one, the answer is just B. Okay, just B. Please, I hope you understand this. So please, A complement is going to be equal to B, and B complement is going to be equal to A, because these two sets are not intersecting. Does this make sense? Are we okay?